Yes.
And then that makes this group up here 3. Let me get this out of
Okay, question. When you're giving priorities
there.
and you're looking at what forms, I guess, the ethyl group and the methyl group, for example, you're only looking at the largest atomic number. But how you said for ethyl is
Yeah.
CH and CH3, you're only looking at just carbon. You're not adding them all together.
No, don't add it. Don't add anything. Just look at the first atom that's bonded.
Okay.
So this is 1.
Just looking at the carbon.
Yes. And
Okay.
then if since they're both the same and have the same atomic number, I got to move out to the next atom to figure out which one is different. You
Okay.
following?
Yes.
You sure?
Yes. I just wanted to make sure.
Okay. So now this is a little different, right? Because 4 is not on a wedge or a dash. So now we have to do something a little bit different. All right. So I'm gonna show you how to do this one too. There's a method for it. There's a method for everything. Right? So if I draw that out as a tetrahedral, I need some room. I'm just gonna take that stereocenter right there. Following? So that's the carbon that's in the middle. And I'm gonna just rotate it. I'm gonna draw it like this. Uh-oh, didn't try to do that. As a tetrahedral. Following that?
That's if you flipped it. I mean,
So all I did was
rotated it.
tilt it back. I'm tilting it back that way.
All of your courses and you were here for the first
Yes or no? I need my, man, I should have got my models.
lesson.
Right, so you see how it's kind of, this bond right here, it's kind of down here.
Which one?
The bond
Yeah.
between these two carbons right here.
Your courses
Oh, yeah.
So all I'm doing is tilting it.
that you had.
And when I do that, that ethyl group is going to be pointed vertically. And then the OH and the methyl group are going to be here.
All right, because you want one, 2, and 3 to be facing you.
Yeah, but I got to get to a point where I can do that first. So I'm going to put this as, this was 2, this was 3. Come on, man. That was 3, this was 1, and this was 4. Is that right?
Yes.
Right.
So what I want to do is get 4 away from me. I want 4 where 1 is.
Right.
So what can you do if we talked about this Friday, I think. You got a tetrahedral like this, what can you do? Can you put a little axis up through here and rotate around it like a rotisserie?
Yeah.
Yeah, let's do that. So if I took that so it's like a carousel, right? Is that right? So if I turned it, y'all didn't, one of y'all told me it was a carousel. And then when I said it, y'all looked at me like I was crazy.
Oh.
So that's 3, right? What's
Yeah.
going to happen to 1? Where is 1 going to come? 1's going to come here, isn't it?
Yes.
And then 2 is going to come here. And then 4 is going to come here. Yes or no? I'm going to circle.
Yes.
Yeah.
So with that one, it's a little bit different. I have a method for doing ball and you can turn any chiral center into a ball and stick model. And the fact that 4 is not on a wedge or a dash, then you got to do something a little bit different. The prioritizing and all that stays the same though.
I got you.
We following?
Yes.
All right, so what is that? So let's put that in the steering wheel. In the steering wheel, it'll look like this, right? So this is 1, that's 2, and that's 3. Is that R or S?
Yes.
It's counterclockwise, isn't it? Going like that. So this stereo center would be what?
Oh, yes.
It'll be S.
Oui.
Yes or no?
Yes.
See, in order for me to determine the configuration of something like that, I can't take the shortcut in this case. Because 4 is not on a wedge or a dash. Bless you.
I have a question.
Go ahead.
So with the 4, we like switched it over. Why did the 4 move up rather than just staying where it was? So I thought we switched it. The 1 would still be in the same spot, being that they're wet.
No. So if we took, let me see if I can put this. I need a blank spot. let's do it right here. So if I have it like this, right? And
Okay.
ethyl group was here, right? And then the OH was here.
Yes.
Mm-hmm.
God dang it, stop it. All right. All I'm doing, so carbon is naturally a tetrahedral, is that right?
Yeah.
Really? I hate it. Sorry. I don't really hate my iPad. I just hate technology when it does what it's supposed to do. So that's naturally what carbon looks like, right?
Yeah.
So all I'm doing is taking this and I'm going to take it and tilt it in that direction so I can make it look like a tetrahedral. And when I do that, what happens to that ethyl group is it's going to be pointed straight up. That's going to be on that vertical axis. And then this group over here is going to be on that little horizontal axis like that. And that'll make this come out and that go back. Every chiral center can be resolved into one of these little tetrahedrals. That's how you do when you have big molecules. You just do each one separate.
So where would the OH be then?
The OH is going to be back here where it is. And then the methyl group that was right here is going to be right here.
We just had to change it because the OH
Yeah.
was number one.
We didn't have a way to do a shortcut with 4 being pointed back already.
Mm-hmm.
And we couldn't apply the shortcut because 4 is on a horizontal line. It's not even on a vertical axis.
So applying the shortcut would make the methyl group like change. Like what was the purpose of applying the shortcut?
No, we
it looks
didn't
exact-
apply. We didn't apply the shortcut.
Okay, you didn't apply the shortcut.
Right. Because let's go back to the examples where we did.
Okay.
Yeah, because it wasn't on the wedge.
You see how like we did this example over here? Replace all this stuff. You see how the H is already pointed back?
Yes.
Right. You see in the other example, let me see. Like if we were to do one like this, you see how the H is already on one of those vertical axes?
Yes.
Yeah. Here, the group 4, the lowest priority group, is not in a position like that. So that's why we had to go through all the rigmarole. So we took that and turned it into a tetrahedral, and then we prioritized. And once you prioritize it, you just need to rotate the molecules so that you get 4 away from you. And the way you do that is to just put an axis like this. This is what it looked like. So we had 2 was over here. So 1, 2, 3, and 4 like that. But we want 4 away from us so we can determine the configuration. Right. So the way you do that is to turn it. Like so, turn it in that direction.
So we turned it and made 4.
So 4 and 1 swap places. It's kind of like turning a dial or a knob, right?
Yeah, but if you turned it, then the 4 would actually be in the spot where the 1 is.
Right.
Turned
And
it like
then 1 would swap places with 2, and 2 would swap places with 4.
Oh, well wait.
Because everything has to move, right? It's all bonded and connected together. So if you turn it, every atom has to move.
What about that 3 then?
The 3 is on the vertical axis, and that's what my axis is. So that's what I'm rotating around.
So the 3 wouldn't move because it's on that vertical axis.
Right.
Okay. And everything else would just shift.
Yeah. It's like being on a carousel at the amusement park, right? The pole in the middle never moves, just the horses.
Okay.
Yeah.
Okay. Thank you.
Yep. All right, let's do a couple of more. We got time to do a couple of more. Make sure I'm on my stuff over here too. I even wrote down some notes. I'm trying to be a better teacher. One day it's gonna happen. All right, let's do B. What about B? That should be easy. It should be quick too. Right? Prioritize it. Is H already going back?
It was R.
H is already pointed back, right?
Yeah.
So then this is going nitrogen. That nitrogen is going to be 1. This side is 2. That side is 3. And then the H is already back, and that's by default. That's 4, right?
Yeah.
Because it's the lowest priority. It's got the lowest atomic number. So what is that? R or S?
Or we're not gonna put
Is it clockwise? Yes, right?
Yeah.
All right, good. I like y'all. Y'all smart. What about this one? Go ahead and knock that out.
Okay, which one? That one?
Yeah.
Okay, H.
This is tricky. That's why I picked it. H is
Oh.
already
Is
back.
it an S?
So that's already back. Now you got these 2 carbons that you worried about, yeah?
So is it?
And then so what do you have to do when 2 of your groups are the same?
keep going down.
Connected.
Keep going. So this carbon and this carbon, right?
Okay.
Now, which one of those 2 carbons is higher in priority?
The,
It's left.
You want to
The
say
right
this
one.
one, don't you?
yeah.
It's got a big old ring attached to it. Is that right?
Yeah.
But it's actually this one
Can you
because of the branches. You see how that has two groups attached like a branch,
Mm-hmm.
and this one doesn't,
Oh.
right? This carbon does, but we're not going to get to that one because the point of difference comes when the branches on this carbon take precedence, right?
Yeah.
So
Right.
that side is going to be higher priority. So this is going to be 2, that's going to be 3, and then chlorine is going to be 1. Does that make sense?
Yeah.
Yeah, that makes sense.
You always want to look for that point of difference when you're comparing your atoms.
Let me R.
Is that R? Everything is R. This must be it. That's R, right? That's clockwise.
Yeah, that's R.
Yeah. It's a holy day. Everything is R, right hand, not sinister. All right, what about this one? Let's do that one. And then we're going to do some Fisher projections. What do you think? We know that if H is on the wedge, what's automatically coming to your mind? I got to reverse whatever I get, right?
Right.
So fluorine is higher than carbon, so that's going to be 1. Yeah.
Yep.
And you got this carbon and this carbon. Which one is higher priority? We just
The
saw
one
that.
on the left.
This one, right? Because it's branched,
Right.
right? So this is 1, that's 2.
What's the difference between that branch and the other one?
Okay, good question. Which carbons are we looking at?
We're 2 and a 3.
We're looking at these 2, right? This one and that one. Is that right?
Yeah.
Yeah.
So this one over here, the branches are immediately seen, right?
Right.
But on the other side, on 3, the branches are on the next carbon over. So they don't count, right? You know, you see these branches before you get to these branches. So that's why this carbon is higher priority than this one. Does that make sense?
Right.
Yeah. So when a carbon has branches on it like that, and you comparing it to another carbon without branches, that's an automatic. It's automatic by default that the branch carbon is higher in priority. I should write that down. I'm gonna use some shorthand. All right, so that branch carbon is higher priority than the other one. Is that making sense? Is it clicking?
That makes sense.
Is it clicking in light of watching the video? Because that's like kind of the groundwork, the introduction part. Right?
Yes.
And once you watch that, even if you don't understand it, when we start doing the examples, then it'll start making sense. All right, let's do some more. This is fun, right?
That's somewhat, I guess.
Well,
All right, let's do, let's do
Wait,
this
so
one.
that one, we flipped it, right? Because hydrogen was
Oh,
space.
yeah.
Yeah.
So how, did we even finish it? I don't think we finished it.
Was S,
3,
so
is
it's
that
R.
right? That would be counterclockwise, but the
Yes.
fact that H is on the wedge, we have to reverse it,
On
right?
the
So it'll be
R.
Holy day. That's 3 R's in a row. All right, let's do F. Let's see what we can do with F.
Okay, that's not bad. So one.
All right, let's do all the chiral centers in F. So let's start with this one. Just warm up. See, because that's going H is already back in it.
Oh.
So what's 1, what's 2, and what's